Hey everybody, and welcome to our lesson on osmosis. So by the end of this lesson, you should be able to explain how homeostasis is maintained in the cell and within an organism in various environments. So we've looked at this standard for plasma membranes, cell transport, and now osmosis. But before we get started, you may want to review passive transport specifically so you can make those connections. All right, so let's talk about osmosis. And osmosis is a form of diffusion, and diffusion is the movement of particles down a concentration gradient. So remember, we always flow from high to low, so we're moving particles from one side to the other. Osmosis specifically is the diffusion of water. So not particles, we're looking at the movement of water through a selectively permeable membrane like our plasma membrane. So osmosis is affected by the concentration gradient, and the concentration difference, we know that's the difference between water outside the cell versus water inside the cell. And most cells are surrounded by water in solution, and they can be one of these three types. So isotonic, hypotonic, and hypertonic. So first, let's talk about isotonic. So isotonic is the concentration of a solution is equal on the outside, like the concentration of water is equal outside the cell as it is inside the cell. Or for a solution, you got the same number of solute particles dissolved in water. Iso means same, so that prefix there means same. So if a cell is in an isotonic solution, they should not experience osmosis here. Okay, there's no net change in movement across the membrane. So if a water molecule goes out of the cell, one is also going right back into the cell to make up for it. There's no net change in amount of water. The cell should not change its shape. It should look the same. In an isotonic environment, the cells will not shrink or swell like we would see in other types of concentrated or dilute solutions. Individual water molecules can and do move, but if one moves into the cell, then another will move out of the cell to keep it no net change. So that means the cell will stay in equilibrium, which is a version of homeostasis. Now we have hypertonic solutions or conditions. So the concentration of the solution is greater than the concentration in the cell, which means they have more solute in the solution, so they have less water in the solution. So hyper means that there is more, so it's more concentrated. More concentrated means more solute in solution, okay? So I don't want you to get confused. And we're looking at the movement of water, but when we talk about a solution, we talk about how much stuff is dissolved in water. If you've got more stuff dissolved in the water, you have less water present. Okay. So if a cell is in a hypertonic solution, then there's less water outside the cell than there is inside the cell, which means that water will leave the cell to balance out with the solution surrounding the cell. If water leaves the cells will shrivel or shrink down, and the pressure within the cell will decrease. If you have a hypertonic solution, animal cells will shrivel. Okay, so they will get smaller. Plant cells will wilt. So if you've ever, you've seen your plants, the leaves wilt and stuff, you say it's because there's not enough water, because water is leaving the plant cells to go and get into the soil of the solution. Well, the soil. And then we have hypotonic solutions or conditions. And this is where the concentration in the solution surrounding the cell is less than the concentration within the cell. So that means that the cell has more solute in it, more concentration. So it's the opposite of hyper. So remember, the prefix hyper means above, hypo means below. So hypo means less, so it's less concentrated. There's less solute and more water outside the cell than compared to inside the cell. So if a cell is in a hypotonic solution, there's more water and less solute outside than there is inside, which means water will rush into the cell. via osmosis. Your cells will swell and the pressure will increase. In a hypotonic solution, animal cells will burst, but the plant cell will become more firm. And I want you to think about why. Why does the plant cell not burst? What does the plant cell have that the animal cell does not? Okay, I want you to think about that. And then you can just look at this little GIF here where it compares the types of passive transport for osmosis. This is a tube that we use in the lab a lot to show the movement or osmosis as a process, and it's called a U-tube. And if you have a concentration gradient, so you have one side that is more concentrated than the other, you will see water leave the less concentrated side to help balance out the ratio on the more concentrated side. So as you look at this one on the left, there's less concentration on the left than there is on the right. So water will move away from the left side, raise the amount of water on the right side to help balance that out, because the particles cannot move through the membrane, but the water can. All right, guys, I want you to pause the video and I want you to copy down this information in your chart.